Cross-zone load balancing. By default, CLB nodes distributes traffic to instances in its AZ only. That means if there is one instance in US East 1A and three instances in US East 1B, and this load balancer gets 12 requests, then one instance will get 6 requests, and the other 6 requests will be served by the three instances. Requests will come to this CLB DNS, which will be distributed evenly to this CLB nodes, then which in turn will distribute traffic to the EC2 instances. But all EC2 instances are not getting even number of requests, which is kind of unfair, right? Enable cross-zone load balancing. Load balancer this time will distribute traffic evenly across EC2 instances. Remember, this is only possible if you add subnets to the load balancer from all AZs where your EC2 instances reside. If you had not added, say, this subnet from US East 1A AZ, then load balancer node from US East 1S subnet will never send traffic to subnet in other AZ. This time traffic would be sent to all EC2 instances in both the AZs. Classic load balancer routes each request to the instance with smallest load. This is an important point to keep in mind. Request is routed to the instance with the smallest load. That means currently whichever instance is serving the lowest traffic, load balancer will send request to that EC2 instance. Don't bother too much about it because eventually the traffic will be distributed. Let's see the components of a classic load balancer. Listeners and health checks are additional components provided by load balancer. And you have to configure these. We have our AZ, subnet, and web application inside EC2 instances in it. Users from internet who want to talk to this application will have to go via the load balancer. Green box is the listener and red box is the health check. Traffic would hit listener. Then the listener will forward requests to the backend instances. Listener configuration is the place where this is done. This is how you'll configure listeners. Front-end port will be used by users or web browsers to connect to the load balancer. In this case, port 80. Backend ports would be where your application is running on EC2 instances. Web traffic would come to the load balancer and it would be forwarded to the backend EC2 instances. So listener configuration specifies the mapping between load balancer port and backend EC2 instance ports. It's not necessary that both ports have to be same. Load balancer port can be different than backend port. Let's see how it is configured using console. Go to the EC2 console. In the left pane, you have load balancer. Click on create load balancer. Currently, you are configuring listeners for classic load balancers. So click on create classic load balancer. In the first screen itself, it will ask you to give a name and then the VPC. After that, you'll see listener configuration. It has two portions. One is the load balancer portion and the other one is EC2 instance portion. So this one says what should be the load balancer protocol and on which port the load balancer should listen to. So in our case, it's HTTP and AT. In the blue portion, you have to mention the instance protocol and instance port. Using this configuration, you are basically mapping the load balancer protocol and port with that of instance protocol and port. So your front-end ports are getting mapped to the back-end ports. You can add additional ports also using this add button. You can choose a different protocol, different port for load balancer and different protocol and port for EC2 instances. As you can see, the load balancer port and EC2 instance port can be different. The reason for having multiple listener configurations is because you can have multiple applications running on single EC2 instance or a set of EC2 instances. If you configure multiple ports, then that means you're using the same load balancer for all the applications which are running your EC2 instances. This is how listener configuration is done. Alright, after seeing the demo of listener, let's talk about health checks now. I told you earlier that load balancer send traffic only to healthy instances. How load balancer knows whether any instance is healthy or not? Load balancer takes help of something called health check to perform this operation. Health checks ping EC2 instances in specified intervals, and if it gets successful responses, then it considers the instances to be healthy. Health check does it continuously all the time. This is how the configuration is done. You mention protocol and which port health checks should ping to. An additional parameter named ping path is also configured. You already have an application running on a certain port and path. It's better to use that rather configuring additional paths. In our case, we are running Apache on all the EC2 instances, and by default Apache runs on port 80. That's why we can use port 80 and the path index.html, which is the basic Apache path, to do the health check on. Health checks would ping all the instances. Now in this case, there was no response, so this instance would be considered unhealthy. Health check supports these protocols. Let's see this using the console. To set up health check, you'll have to go to the same screen, EC2 console, load balancers, and then create load balancer. After setting up all the required details, finally come to configure health check screen. This is where the health check is set up. Now let me first go through the advanced details. This is how the architecture of health check is. You have health check here and then EC2 instances. Health checks keep pinging EC2 instances every now and then. After pinging EC2 instances, it waits for a response. Health check cannot wait forever to get the response. So response timeout mentions how long health check would wait to get the response. If it does not get the response during this time, then it will consider this ping to be unsuccessful. Here we have mentioned 5 seconds. That means health check would wait 5 seconds to get the response back. If it does not, then this ping is unsuccessful. The next option is interval. So as I said, health check keeps on pinging EC2 instances every now and then. So using interval, we say that after this time health check should ping. That means if the first ping goes at say 12 am, then the second ping would go after 30 seconds. The third ping would go after 60 seconds, so on and so forth. That means every ping to each EC2 instances has a gap of 30 seconds in between. That's what interval says. Then we have unhealthy threshold. Unhealthy threshold says when health check should consider a particular EC2 instance to be unhealthy. 2 means if it does not get a response for 2 consecutive times, then that EC2 instance would be considered unhealthy. That means health check sent a ping the first time. It did not get a response. It will still not consider this EC2 instance to be unhealthy. It sent a ping second time. It did not get a response. Then in that case the EC2 instance would be considered unhealthy. Remember, it has to be consecutive. That means instead of 2, if I mention say 5 here, to consider this EC2 instance unhealthy, health check should not get response 5 consecutive times. If it gets a response in between, it will reset the clock, it will start again. So this is 5 consecutive times that health check did not get any response, then it will consider that particular EC2 instance to be unhealthy. In case of healthy threshold, as it is 10, health check would consider a particular EC2 instance to be healthy only if it gets successful response 10 consecutive times from that particular EC2 instance. That means it will ping the EC2 instance 10 times consecutively after an interval of 30 seconds. And if it gets successful response each and every time, then EC2 instance would be considered healthy. If you see in this case, to consider an EC2 instance to be healthy, it will take approximately 5 minutes because the interval is 30 seconds and the healthy threshold is 10. That means 10 consecutive ping should get successful response. 30 into 10, 300 seconds. So for this health check to consider any of the EC2 instances to be healthy, it will wait 5 minutes. If there is a break in between, that means after 8 successful responses, that particular EC2 instance did not send another successful response, it will reset again. So it will wait for another 10 consecutive successful ping responses to consider that EC2 instance to be healthy. Then you have ping protocol and ping port. As I said earlier, typically ping protocol and ping port should be the port and protocol where your application is running. You do not want anything else or something extra to be running in your EC2 instances just because of your health check. We'll be running Apache on port 80 and the path would be /index.html. So we are not mentioning anything else because health check would ping the existing application port. So we do not have to set up separately for health check in the EC2 instances. Ping path is something from where health check would see if it gets any data back or not. In our case, if you have noticed so far, I have been creating a page, the coloring web page, basic web page in the path index.html. So health check will go and ping that path and see if it gets any data or not. If it gets any data, that means it is successful. Now, there are two benefits of using health check. First, you check whether your EC2 instance is up or running or not. All the EC2 instances are currently in running state. That is one thing. And the second thing, even though your EC2 instance is up, your application might be down. Something might have gone wrong in the program or in the logic which took down the application. So if you mention the same port in health check where your application is running, you're making sure that your application is also healthy. So the benefits are twofold using health check.